Hello, I'm Jaden Kim, and this is channel ScienceBlog. So, we're going to talk about the mysteries of the universe, and this is sort of a book that I'm writing on myself, and I'll share some questions that I learned to answer with science with you. So, okay, some of you might know what stars are, but 5-year-olds or little young people think stars are this size. And soon maybe they'll think that stars are about this size, and then they'll probably know that it's bigger than the sun. Or about smaller, but anyway, it's bigger than the Earth. A million times bigger than ourselves. So, let me explain about stars. Let's get started. So, a star lives in, what's a star's life cycle? Yeah, and everybody wants to know. So, probably much people know about the word supernova. That's like the explosion that happens at the depth of a star. To explain it a little bit difficultly, first of all, let me explain that to explain a supernova more difficultly, if there is enough fusion in the core, radiation and gravity will stay balanced. Okay, and a sun can hold light elements, but more massive stars would hold more heavy elements until they reach iron. Iron, unlike all the elements that went before, the fusion process that makes iron does not create any energy. So the iron is in the center of the star until it reaches a critical amount, and then the star balance would be broken, literally. Like gravity will go to up and radiation will go to down. So the balance is broken now, so nobody knows what will happen. Everyone except scientists. So nobody knows except this book and some scientists and some boys and girls. So maybe some people know. So the balance will be broken and the core collapses. And with a fraction of a second, the star implodes, moving at a quarter of the speed of light, feeding more mass into its core, and it's when all the elements in the universe is created when a star dies in a supernova explosion. So probably you'll say, "Oh, sorry star, this is your end." But just wait a little bit longer. So that a big explosion can send a huge amount of energy, and if the star is massive enough, the entire mass of its core will collapse into a black hole. The whole part of a black hole is the singularity, and we're not sure what it is exactly. It might be indefinitely dense, meaning all its mass is concentrated into one single point in space. And there's some other stuff to go about black holes, but now we're focusing on stars. And now we're focusing on kinds of stars, like dwarfs and like red giants and blue giants. But we'll explain about that later. And right now, we're going to see what is a neutron star, which is made if that star is not that massive enough to become a black hole, and not that small, unmassive, I think, enough to be like the sun. So it will be like just in the middle, and then it will become a neutron star. A neutron star is probably, you know what a neutron is. It's a part of an atom that doesn't have any charges, and just to get balance, it stays there. Neutron stars are one of the most violent things in the universe. Giant atomic nuclei. Nuclei means nuclear, many kinds of nuclear, many nuclear. So it's like octopi. Many octopus, you call it octopi. Well, some people do. And some people say octopuses, but I think it's more definite to call it octopi. It's more simpler. So, anyway, giant atomic nuclei, only a few kilometers in diameter, but as massive as stars. So, massive means not that big. Maybe it has a full mass, super big kind of mass. So, one little teeny tiny space. And if it was anything, it would become breath. That's my alarm. Sorry. So, we need to say bye-bye soon. So, first of all, this is what neutron stars are in a little bit non-difficult way. And now, let's go into a very funny part, which is called the nuclear pasta. Yeah. Do you like pasta? Well, don't eat this one, because it's the one in space, and if you go into space, your eyeballs will pop and your blood will boil. Apparently think boiling means getting hot, but that only happens on Earth, and in space, boiling just means like boiling. We'll explain a little about boiling later, because it's not about space. You learn that in another video. But anyway, so your blood is gonna boil, your eyes is gonna pop, your skin is gonna... So, and also nuclear pasta, if you try to eat it, it's totally almost indestructible, so it'll break your teeth. Literally. Really. Break your teeth. Nobody will like it. Not even the dentist. So, basically, it's unbreakable. Lumps of pasta are, as you know, there are steps of iron. So let's say, yes, it gets interesting. So a neutron star is just like a planet. It has an atmosphere, and it has a crust, and it has a core. First, we'll go to the crust part, and we'll explain about the core part on neutron star 2. So the crust part has a little bits of iron in it still. Iron left over from the supernova squeezed together in a critical lattice with a sea of electrons flowing through them. Going deeper, gravity squeezes nuclei together to find fewer and fewer protons as much of them merge into neutrons. Obviously, that's why it's called a neutron star. Probably. Until we reach the base of the crust, and here, nuclei are squeezed together so hard that they start to touch. Protons and neutrons rearrange, making long cylinders or sheets, enormous nuclei with millions of protons and neutrons, shaped like spaghetti and lasagna, called nuclear pasta. Yeah, that's why they're called nuclear pasta, but technically they're not pasta, so don't eat them. And don't go out of space with outer space dude. Or very good training or trained body. And now we'll explain about the core later on video 2, because there is a lot of interesting stuff in the core. So there can be even like strange matter, which is made from strange quarks, and that will be explained a little bit later. I think I used a little bit too much later in the story, but yeah, only I can do that. So, okay, I hope you enjoyed the video, and you don't have to subscribe. Yeah, no, you don't have to, but I really like if you would. Everyone likes it, but you don't have to if you don't have time. I in fact wasted 3 whole minutes just subscribing a video after I watched it, and it's a little bit annoying if you don't want to do it. Yeah, just keep it in your mind if this video is good. If this video is that cute. Yeah, that's okay. Okay, so bye. See you later on ScienceBlog 2 about neutron stars.